Hi to everybody, and I welcome to today's lecture on different system of packaging. In the last class, we had held what's the importance of packaging, how packaging help in marketing, and different packaging materials. In today's class, I'll be talking about the different system of packaging. So if you take the package profile of meat and meat products, it depends upon basically the three things. One is the type of products or the type of processing. Whether it's a cured product, fresh product, or you are going with dried meat products or retorted products, the packaging will be varying. Condition of storage, again, whether you are going to store at freezing temperature or chiller temperature, and distribution system, how you are going to distribute the meat and meat products. All these factors will affect the package profile of meat and meat products. So coming to the importance of meat packaging at retail levels. So what are the factors that will affect the consumer purchase at the retail level? If you see that one of the most important thing is the meat color, then how the package looks, shelf life stability of that product, juiciness of that product, sensory attributes like texture, odor, package integrity, package appearance and convenience, how it can be used, and labeling. So all these factors will affect the consumer choice of the muscle-based products. So coming to the color, basically in the meat, in the fresh meat, we can come across three colors. One is the most desirable color, that is called the bloom, that is oxymyoglobin. It's nothing but the cherry red in color. Another is deoxymyoglobin, which is purple in color. In oxymyoglobin and deoxymyoglobin, the iron is in the form of ferrous state, and deoxymyoglobin is formed especially during the vacuum packaging, where the oxygen concentration is very less. Oxymyoglobin is formed when the partial pressure of the oxygen is high. So the myoglobin combines with oxygen to form oxymyoglobin, and it gives a cherry red in color. In intermediate between these two, we get what is called as a metmyoglobin, when the oxygen partial pressure is low. So here iron is in the form of ferrous. In oxymyoglobin, the iron is in the form of ferrous, but in the case of metmyoglobin, the iron is in the form of ferric. So these are the three colors we can come across. This is oxymyoglobin when it combines with oxygen. When it is under vacuum packaging, when the partial pressure of the oxygen is very less, we get a purple color, and we have the partial pressure of the oxygen is less, then we have what is called as a metmyoglobin. It is easy to convert the deoxymyoglobin to oxymyoglobin on exposing to the oxygen, but it is very difficult to convert the metmyoglobin to oxymyoglobin even on exposing to the oxygen. So this is the importance of color. The most desirable color is oxymyoglobin. So what are the problems associated with the meat packaging? That is mainly at the first level of packaging. One is exposure to the oxygen. If you are exposing more to the oxygen, there can be oxidative rancidity can take place. Another is moisture loss. If the moisture loss is more, it will be affecting the juiciness and color of that product. Third is the odor. Odor development occurs principally through the production of volatile gases while the production of packaged gas interactions. So due to the spoilage, some bad odors can be developed. That due to the picking up the odors from the outside or the flavors from the outside, especially the meat will be containing more of fat. The fat will pick the external odors very easily. So these are the factors or the problem associated with the meat packaging, especially at the first level of packaging. So what are the qualities of the fresh meat is affected, or what are the things that will be affecting the quality of the fresh meat. One is the microorganisms. So growth of the microorganisms can affect the color, odor, taste. Enzymes activities, again the endogenous enzymes activities can also affect the color, flavors and other problem. Oxidations, when it is exposed to the oxygens, it can lead to oxidative rancidity. So growth of the microorganisms, enzymes activity and oxidations can affect the color of the fresh meat, can affect the odor, can affect the taste and texture. Because of this factor is affected, it can reduce the salability of that product, or it can make the product unsaleable. So what are the factors that we have to take into consider when we are going for packaging of the fresh meat? The principles of fresh meat package include, first, it should offer a desirable color, that is the bloom, which we have discussed already. So the myoglobin has to combine with oxygen to form oxymyoglobin. So the package material should allow the oxygen to get into the package. Next is, it should prevent the moisture loss. The moisture loss should be prevented. If it is not preventing the moisture loss, it will lead to the change in the color of the meat, as well as it can reduce the juiciness of the product. It can also lead to freezer burn conditions, which we have discussed in the previous class. You should not allow too much of oxygen to pass in also. If it allows too much of oxygen to pass in, and if it is containing the fat, it can lead to the oxidative rancidity. And it should prevent the further microbial contaminations. It should not allow the pickup of foreign flavors or the odors. It should be grease proof, and it should have sufficient tensile strength so that it can withstand the freezing, and it should not get torn off easily during the transportations and during the display. So coming to the packaging of fresh meat, the first system of packaging is the tray with overwrap. So tray with overwrap means we'll be using the polystyrene trays. So this is the polystyrene trays. The polystyrene trays are nothing but the thermocols, you can see. So this is called an expandable polystyrene or high impact polystyrene trays. And we can also use certain plastic trays like polypropylene trays, which have very good strength. And this, inside this tray, we'll keep the meat and the meat products, and it is covered with other cover that is called as an overwrap. So it is covered with an overwrap. This overwrap should be transparent, so it is easy for the consumer to see the product. In the case of fresh meat, especially the red meat, the overwrap should allow sufficient oxygen to get in, so it can form oxymyoglobin. The overwrap that is commonly used for the meat is LDP, rubber hydrochloride, high plasticized PVC, and biaxially oriented polystyrene. By this packaging, we'll have a shelf life of 8 to 10 days, and we will be able to maintain the color of this product around 4 to 5 days in the tray with overwraps. In the tray with overwraps, we'll also be using what is called as blotters. So blotters, what is blotters? Blotters are nothing but the absorbent pad. Is usually placed under the meat to absorb the purge or the drip. So you know that when you keep the fresh meat in any container, the fluid will be coming out of the meat and it will be affecting the consumer appeal. So the fluid has to be absorbed. For that, we will be using what is called as blotters. So these are the absorbent meat pad, we can say, or called as blotters. This pad is kept underneath the meat. So whatever the fluid that comes out, it will get absorbed and it gives a neat appearance. These pads are generally placed just below the meat, or sometimes it is placed below the false base, we can say. So the pad will not be appearing outside, but inside the two bases, that is false base and the real base, in between the pad will be placed. So whatever the fluid that comes out through this holes, it will get absorbed into the pad. So you can see the difference here. This is without the pad. So you can see the fluid is accumulating. This is with the pad. There is no accumulation of the fluid because whatever the fluid that comes out is absorbed by this pad. Next is the cellophane. So cellophane is one side of the cellophane So this is a cellophane. One side of the cellophane will be coated with nitrocellulose. That is the outside. And the surface which comes in contact with the meat, it is not coated with nitrocellulose. So on one side will be coating with nitrocellulose. So once you keep the meat, it will be losing certain fluids. These fluids will be absorbed by the cellophane. So once it absorbs the moisture, it will increase the oxygen permeability. So the oxygen will be getting inside and it forms oxymyoglobin. But at the same time, why we give nitrocellulose coating is that it will prevent the moisture loss. So it will be able to maintain the juiciness of that product. So outside, we keep nitrocellulose coating, inside the cellophane. So the nitrocellulose coating will prevent the moisture loss from the meat. So uncoated side kept in contact with the meat, the moisture saturation on the inner side of the film increase its oxygen permeability. The oxygen gets in, it combines with the meat to form oxymyoglobin and it gives the bloom. Next is the string film packaging. This is mainly used for the large and uneven cuts. So which is usually stored under frozen conditions, say even up to minus 45 degrees centigrade. We generally store this large and uneven cuts, especially the carcass quarters. So for carcass quarters, we will be using this string film packaging. And this is normally recommended for the frozen storage conditions. So the packaging material we use should have good water vapor barrier properties. And it should have high structural strength. And it should have a strength or it should not become brittle even if you keep it at minus 45 degrees centigrade. The material that is commonly used are heat-shrinkable PVC, PVDC, polypropylene, irradiated polyethylene, and rubber hydrochloride. So what are the advantages of string film packaging? So it forms the counter-tight package. So it gives a neat appearance. So it forms a tight package or it gets attached to the surface. So it gives a neat appearance. It is easy to handle. It forms the counter-tights, that's what I told you. And it gives an appealing display. So eliminate the pockets for purge accumulation. So it will be it will become skin tight. So there is no space for the fluids to come and accumulate. So you can see this is the irregular cuts. For such types of cuts, we can go with string film packaging. So for the string film packaging, we'll be using what we call as air tunnel or water tub, which is maintained around 90 degrees centigrade. So here, the hot air tunnel are used to effect the tight wrap, or it is dipped in the water tub maintained at 90 degrees centigrade for few seconds. So we'll be putting the meat pieces inside this package and then it is put in the hot water so that it will shrink and it form counter tight. So let's see how this is done. So you can see here, the meat is put in a cover and you can see it forms in hot water which is maintained around 90 degree. So it forms the skin tight. So you can see here, the big cuts are taken. So this is also string film packaging. The next system of packaging is the vacuum packaging. In the vacuum package is mainly used for the primal cuts and subprimal cuts. In India, we are mainly using for the buffalo meat. And here the shelf life can be increased to 8 to 10 weeks at 0 degrees centigrade. In this packaging, we are removing the air or the oxygen is completely removed. So we are creating an anaerobic system and that will prevent the oxidative rancidity and it will also prevent the aerobic bacterial spoilage. So you can see here, so what are the precautions you have to take care while doing the vacuum packaging? So coming to what are the precautions that you have to follow during vacuum packaging? There should be minimum delay between the boning and packaging of the meat. Next is the pH of the meat while packaging should be less than 5.9. Otherwise, the hydrogen sulfide producing bacteria dominates in the meat, resulting in greening after say around 2 to 3 weeks. So it forms what it calls the green self-myoglobin. So always see that the pH of the meat is less than 5.9 when you are going for vacuum packaging. Then oxygen concentration should be less than 500 ppm. Otherwise, we get what you call as a met myoglobin. So when you expose to the oxygen, we cannot convert this met myoglobin to oxymyoglobin. So the oxygen pressure, the oxygen concentration should be less than 500 ppm. So if you want to develop this oxymyoglobin, the partial pressure of the oxygen should be between 30 and 760 mmHg. If the oxygen pressure is between 1 to 1.4 mmHg, then it forms met myoglobin. So you see that the oxygen concentration inside the packaging material is less than 1%, or it should be less than 500 ppm. Okay, so that it will not form the met myoglobin. And see that if you want to have an extended shelf life, see that it is the temperature of this vacuum packed meat is always maintained near to 0 degrees centigrade. So that will help to extend the shelf life of the vacuum packed meat also. The vacuum packaging materials, as I already told, we can go with the laminates. Normally laminates are used. It may be film laminates or film laminates, plastic films with aluminum foils will be using, or film laminates will be using, which we have discussed already. So these are the different laminates that you can use for vacuum packaging. Lamps and poles are generally less vacuum packed. What's the reason for that? Because the lamb meat has higher pH. So when it's have the higher pH, naturally it will favor certain types of bacteria, that is hydrogen sulfide producing bacteria. So it can favor, especially the Brocothrix thermospecta. Such type of bacteria can develop, and it can give the greening of the meat. Okay. And normally the pork start with a large load of bacteria. That is why we generally will not go for vacuum packaging. Generally we will not go for vacuum packaging of the lamb and the pork. The shelf life 8 to 10 weeks at 0 degree centigrade for buffalo meat. For boneless, it is 2 weeks at 1 degree centigrade. Okay, coming to the type of packaging machines, there are two types of packaging. One is a nozzle vacuumizing and chamber vacuumizing. So in the nozzle vacuumizing, it's very simple. Here we keep the food materials in a laminated cover, which will not allow the oxygen, which will not allow the moisture to get in. And then it is the neck of that cover is kept to this nozzle, and the vacuum pump is switched on. So when the vacuum pump is switched on, it absorbs complete moisture, complete atmosphere, and the bag will collapse and it creates a vacuum, and it will create an anaerobic conditions here. Then the cover is sealed, or it is clipped with certain metal wires. Normally we use the aluminum wires. It will be clipped in the neck. So this is a simple methods, but the disadvantages, we will not get high vacuum inside the cover. Next, coming to the chamber type, there are two chambers we can say, that is vacuumizing chamber and ballooning chamber. So this is the vacuumizing chamber, and the ballooning chamber. The product will be placed here. So first what we do is, the pressure will create high pressure inside the, or rather we will be reducing the pressure outside. So once we reduce the pressure outside, what happens is the ballooning, because of the ballooning will be taking place inside the package. Then what happens is, this air will be removed. So the package will collapse and it forms a vacuum. A vacuum will be created when the vacuum pump is switched on. So the bag containing food is placed inside the chamber, is vacuumized and then sealed by the impulse systems in the vacuum sealing chamber, and it will be sealed. So let's see what is happening here. So this is the chamber where we can keep the material to be vacuum packed. First, there will be ballooning of this cover will be taking place. You can see it is ballooning. It is because the outside pressure is less. Then the air inside the package will be sucked. The package will collapse. That is what happening in the next stage. And it is impulse sealed. Now the package is collapsed and it is impulse sealed.